Scientifically, time travel is the idea of moving between specific points in time, comparable to movement between various points in space, with the help of an imaginary device which could be termed as time machine or a portal that connects distant points in time. Time travel is a well-known conception in works of fiction and philosophy, but travelling to a random place or point in time has a narrow explanation in theoretic physics and normally in aggregation with a wormhole or quantum mechanics. In an additional constricted sagacity, travelling in time one way in the future through time dilation is a recognized occurrence in special theory of relativity. However, travelling a noteworthy distance needs motion at speeds equivalent to the speed of light, which is not practical for a man to travel with the current technology. This thought of time travel had been used in many fictional works, but was best explained and made popular by H.G. Wells in his book The Time Machine, published in 1895, that took the imagination of the people about time travel to a completely different level. There are many famous series that have shown time travel in a complicated and sophisticated way, which seems real at times. Star Trek, Back to the Future and Doctor Who are some of the famous ones. Humans have been shown travelling in time with the help of a vehicle or a machine and shuttle between past and future. However, the reality is much disarrayed. While some scientists say it is possible to travel in time, some of them disagree to it. There are many explained theories on time travelling which explains the probability and the improbability. History of time travel. A. Time machines. The fictional stories involving time travels have been with us for quite some time now. The first ever mention of time travelling through the means of a machine was made in a short story, The Clock That Went Backward, written by Edward Page Mitchell in the year 1881. In the story, this unusual clock took people back in time when wound backwards. There were later comments as to whether or not a clock counts to be a machine. However, later, in the year 1887, Enrique Caspar Irimbau published a story, L'Anachronopete, which features the first ever machine engineered for time travelling. In 1895, H.G. Wells' book, The Time Machine, propagated the idea of time travel by mechanical means. B. Time travel to the past. The origin of time travel is uncertain. There have been many writers who have written fantasy stories based on time travelling. Samuel Madden's work, Memoirs of the 20th Century, written in the year 1773, consists of letters from the British ambassadors in 1997 and 1998 to the envious in the past. These letters convey the religious and political conditions of the future. The narrator seems to have received these letters from a time traveller from the future, which he calls to be his guardian angel. Not many writers like Alexander Veltman and Charles Dickens have written famous stories which involves travelling back in time. But truly, the book Paris avant les hommes, written by Pierre Boutillard in the year 1861, gave a clearer idea of time travel in the past. In the story, the character is transported to the past, in the prehistoric age, where he interacts with ancient creatures and comes across an ape-like ancestor. C. Time travel to the future. The mention of time travel to the future has even made its place in the Mahabharata, where King Ravyataka Kudmi travels to the heaven to meet with Brahma, the creator. When he returns to the earth, he shockingly learns that many years have passed. There is a Japanese legend of a fisherman, Urashima Taro, who rescues a turtle, and as a reward by the turtle, he gets to visit a palace undersea. He returns home after 3 days, only to find himself 300 years have passed in his absence. Theory of time travel. There are a few theories, special and general relativity being the most notable out of them, which suggest that appropriate geometrics of space-time, or particular types of motions in space, might make time travel into the past or the future possible. The commonly accepted and also well confirmed physical theory regarding the relationship between time and space is called the special relativity. Moving away from the Earth at special relativity velocity and returning would show that more time would have passed on Earth than that for the one who is travelling. Therefore, it can be said that relativity permits time travel. While many scientists believe that time travel is impossible, there are many who have spent their lives in the study of theories of the same. Here are a few of the theories of time travel. A. Wormhole. While many scientists believe that time travel is impossible, there are many who have spent their lives in the study of theories of time travel. According to NASA's study, general relativity could allow travelling back in time. However, the equations would be physically difficult to achieve. Out of many, one probability is to travel faster than light, which is 186,282 miles per second in vacuum. Another possibility is to create a wormhole between points in space-time. This is very much possible by the equation provided by Einstein, but they would collapse very swiftly and would be suited for small particles only. The wormholes have not been observed by the scientists yet, plus the technology required to create a wormhole is far beyond our reach today. B. Infinite cylinder. An astronomer by the name of Frank Tipler projected a mechanism in which matter worth 10 times the mass of the Sun should be taken and then rolled into a long and dense cylinder. The cylinder should be set to a spinning motion at the speed of a few billion revolutions per minute. Any spaceship close by could get itself on a closed time-like curve according to the Anderson Institute. There are few limitations to this method though. The length of the cylinder needs to be infinitely long to make this work. C. Black holes. One more theory is to move a spaceship speedily around a black hole. This theory was suggested by Stephen Hawking in one of his writings in the Daily Mail in the year 2010. He added that the speed at which the ship should move should be more than that of the light, only then will the theory work. D. Cosmic strings. Time travel is also known possible through the theory of cosmic strings, which are narrow tubes of energy and are stretched across the entire universe. These regions are known to have enormous amount of mass, which would allow them to wrap the space-time around them. These cosmic strings are either in loops or infinite. If two such strings are parallel to each other, it would bend space-time to such a particular alignment that time travel would be made possible in theory. Science of time travel. Time travel is only possible theoretically by the following methods. Travel at a speed faster than the light, black holes and cosmic strings, wormholes and Alcubierre drive. A. Travel at a speed faster than the light. As per the study of special relativity, a matter or a signal moving at a speed faster than that of the light from one point to another would appear in an inertial frame or moving backwards in time. In an experiment of a signal being sent to and fro, A and B, at the speed of FLT, faster than light, A would receive a reply even before sending the original signal. This is a simple violation of causality of time frame. This scenario is often referred to as tachyonic anti-telephone. B. Space-time geometrics. Gravity is covered under the special and general relativity, exemplifying it in the curvature formed in space-time caused by the flow of momentum and mass energy. The entire universe is described as a field equation by general relativity. The answers to these equations results in closed time-like curves, which leads to time travel to the past. The first one to propose such a theory was Kurt Gödel. His theory was known as Gödel metric, but his and many other theory involves the presence of physical characteristics in the universe, which is not quite possible. Wormholes theory. Wormhole is a conjectural warped spacetime that is also accepted by the Einstein field of equation of general relativity, even though it wouldn't be probable to travel through a wormhole except if it were a traversable wormhole. Time travel would have conjecturally happened in this way if a traversable wormhole is used. An end of the wormhole is speeded to a certain fraction of the speed of light, possibly with a radical propulsion system, and then transported back to where it started. Another way could be to move one of the entrances contained by the gravitational field of an entity, which has more gravity compared to the other entrance, and then bring it back to a position close to the other entrance. In either of these methods, time dilation lets the end of the wormhole, which has been simulated to have matured or aged less in comparison to the statutory end when perceived by an external spectator. Nevertheless, time bonds diversely through the wormhole in comparison to its exterior, so that harmonized clocks at both the ends of the wormhole continues to be harmonized when perceived by the spectator crossing the wormhole, irrespective of the way the ends move about. So a spectator going through the speeded end would come out of the stationary end when the stationary end was of the same age that the speeded end was the time prior entrance. For instance, if before going in the wormhole the spectator observed a clock at the speeded end had a date of 2011, whereas a clock at the stationary end had a date of 2016, then the spectator would come out of a stationary end when its clock also had the date of 2007, a journey back in time, as observed by the spectators outside. An important drawback of this type of time machine is that one could travel only till when the machine was made. In principle, it is more of a passage through time than a machine which travels through time and will not let the technology to travel back in time. As per the present concepts on the identity of wormholes, building a traversable wormhole would need an ingredient that has negative energy or exotic matter. Theoretically, wormhole spacetime needs a dissemination of energy, which disrupts many energy conditions like the null energy condition and the strong, dominant and weak conditions of energy. Quantum effects have been known to cause slight quantifiable defilements of null energy condition, and physicists consider that the need negative energy could in fact be likely because of the Casimir effect in quantum physics. Though calculations proposed a very huge quantity of negative energy would be needed, later calculations displayed that this requirement could be made randomly less. C. Other approaches. There are other approaches suggested by many researchers who were into the study of time travel. One of them is the tipless cylinder, which involves dense elongated cylinder into a spinning movement of few billions per minute. Same can build by a cosmic string. However, it is impossible to create a cosmic string and none are identified to exist. On the other hand, Robert Forward, who was a physicist, noted that a simple application of general relativity to quantum mechanics could be used to build a time machine. He suggested that if a heavy atomic nucleus was kept brought in a strong magnetic field, it would elongate it into a cylinder whose spin and density are enough to make a time machine. If gamma rays are projected at it, it might allow information to be sent back in time. However, there are only possibilities of such things. Until and unless it is experimented, such speculations are all but gibberish. D. Experiments. Some experimentations done leave an imprint of reserved causality but are a matter of understanding. For instance, in the delayed choice quantum eraser, Marlon Scully did an experiment where pairs of entangled photons were distributed into idler and signal photons. Signal photons emerged from one-off locations and their situation was later measured as in the double-slit experiment. The experimenter could study the location that the photon came out from depending on how the idler photon was measured. This information could also be erased. Although the signal photons could be measured prior to the selection of idler photons, the choice retroactively defines if an interference pattern is witnessed when one associates measurement of idler photons to the resultant signal photons. Since intrusion can be perceived only after the idler photons are measured and interrelated with the signal photons, experimenters don't have any other way to detect the selection that would be made earlier simply by observing the signal photons. And under most clarifications of quantum mechanics, the consequences can be clarified in a way that does not disrupt causality. In the experiment conducted by Liun Wang, a violation of causality has been seen as packages of waves were sent through a bulb of cesium gas in a way that the package seemed to come out of the bulb 62 nanoseconds before it entered it. However, since a package of wave is not a proper defined object, instead a sum of multiple waves of various frequencies is, and the package could seem to move quicker than light or backwards in time, even if no pure waves in the totality do so. No energy or information can be sent through this effect, so this experiment too was considered not to violate causality. Alfons Stahlhofen and Gunther Nemtz from the University of Koblenz said that they violated the theory of relativity by Einstein as they transmitted photons much faster than the speed in which light travels. According to them, in an experiment conducted by them, microwave photons travelled rapidly amid two prisms which had been separated to 3 feet apart using an occurrence termed as quantum tunneling. Other physicists denied accepting this phenomenon, as it doesn't permit any transmission of information faster than light. In an experiment conducted by Shengguang Du, he generated 2 single photons, passed one through vacuum and the other one through rubidium atoms cooled with laser which slowed down light. In both the cases, the precursors headed the chief bodies of photon and travelled at the speed of light in vacuum, violating causality. Most of the media thought this experiment to be an evidence of travelling back in time with the help of superluminal speeds. E. Non-physics-centered experiments. There are many experiments which have been conducted outside the boundaries of physics to lure future humans who could have invented technology of time travel to come back and show people of the current time. Way back in 1982, Baltimore, Maryland, a group known as Chrononauts had an event that welcomed visitors from future. In 2005, there was another event organized, MIT's Time Traveler Convention, or Perth's Destination Day, which profoundly broadcasted enduring advertisements of a gathering time and place for all the future time travellers. These hosted events or experiments were only a possibility of attracting any future time travellers, but there have been no evidence of such visitors who have attended these events. It is theoretically possible that there have been people who have travelled in time backwards, but they have travelled to the meeting in a universe which is a parallel one. Another aspect is that all the devices constructed to travel in time are a part of physics. It is not possible to travel back in time prior to the making of the time-travelling device. Time travel to the future in physics. There are several ways in which someone could travel in future in a bounded way. The person could fix things up so that in a minor extent of their individual independent time, a huge sum of individual time has passed for other human beings staying on Earth. For instance, an onlooker could take a journey far from Earth and come back at a relativistic velocity, with the journey enduring for just some years as per the clock of the onlooker, and then come back to see how many thousands of years have gone by on Earth. This is subject to the selection of coordinates selected to travel in time. This type of time travel in future has been displayed in very minor time scales and is applicant for any time scale. It could be functional with the help of velocity-based time dilation, which come in the theory of special relativity. For example, journeying at speed equal to that of light to a far-away star, then reducing the speed, turning around and then journeying back with the same speed of light back on Earth as mentioned in the twin paradox. This can also be used by applying gravitational time dilation in the theory of general relativity, for example, being located in a big hollow dense entity or staying just out of a black hole or the event horizon, or exactly close to a body whose density and mass leads to enough gravitational time dilation close to it. A. Time dilation. In the general theory of relativity, Albert Einstein says that the relative given to onlooker, time passes quite slowly for the bodies which are moving quickly to that onlooker or bodies which are situated deep in gravity well. For instance, a clock that is moving relative to the onlooker will be calculated to move slow in that onlooker's rest frame. As a clock nears the c, speed of light, it will almost come to a stop. Though it can never match the speed of light, it can never stop completely. Two clocks that move inertially, frame of reference, relative to each other, this impact is mutual with both the clocks measuring the other to be indicating slower. Nevertheless, the regularity is disrupted if one of the clocks starts to accelerate, as in the twin paradox, when one of the twins travels to space while the other remains on Earth. And when the traveller twin returns back, both agree that the one who was travelling has aged less. As per the general relativity time dilation, impacts also happen if one of the clocks is situated in a deeper gravity well in comparison to the second one, where the clock situated deeper ticks slowly. This effect should be taken into account while standardizing the clocks on the satellites of the GPS, Global Positioning System, and it could usher important changes in the proportion of aging for the onlookers at various distances from a black hole. In general relativity, as per the calculations, a human being could time travel forward 4 times than that of the distant onlookers by staying in a shell that is spherical and has a diameter of 5 meters and the mass of Jupiter. To such a person, 1 second of their individual time would relate to 4 seconds of their distant onlookers. Shrinking the mass of such a huge planet into a small structure is not possible for the technologies that we have now in the present. There are many proof of experiments which back the legitimacy of equations for gravitational time dilation in general relativity and velocity-centered time dilation in special relativity. An example could be the surveillance of atmospheric muon decay. With the present expertise that we have, it is possible for a time traveller to age quite less in comparison to his friends on Earth, by just about 20 milliseconds for Sergei Advavev that has been recorded. Sergei is a researcher who is trying to use lasers to loop space-time. B. Time perception. The apparent time interlude amid 2 consecutive occasions is denoted as perceived duration. An individual's perception of time cannot be openly felt or understood, but it can be quantitatively researched on and concluded through various types of scientific experimentations. Time perception is a creation of the intellect which can be manipulated and slanted under some situations. These chronological delusions help to uncover the fundamental neural contrivances of time perception. For any living beings, time perception can be ostensibly hustled up by hibernation, where the metabolic rate and body temperature of the being goes down. Something more extreme in nature could be suspended animation. Here the proportion of chemical progressions in the individual would be lessened extremely. Both suspended animation and time dilation permit travel to the future and not the past, so neither of them violate the causality, and it is arguable whether or not they should be referred to as time travel. Nevertheless, time dilation could be seen as a better explanation for our awareness on time travel than suspended animation, as with time dilation, lesser time actually passes for the traveller than those who stay back. So the person who travels could be said to have reached the future sooner in comparison to the others, but nothing of these things happen in suspended animation. Philosophical understandings of time travel. Philosophies of time travel are perforated with queries about connection and absurdities. Compared to other essential perceptions in contemporary physics, time continues to be a mystery and hasn't been clearly understood. Theorists have been hypothesizing about the nature of time even before the eon of the antediluvian Greek theorists. Many theorists and physicists who study the nature of time also research the likelihood of time travel and its rational insinuations. The possibility of contradiction and their potential explanations are every so often deliberated. A. Grandfather paradox. A topic often taken up in logical conversation of time is the notion that if it was possible for an individual to go back in time, contradiction might succeed if the time traveller were to alter things. Some of the common examples of this is the grandfather paradox and the thought of autoinfanticide. Here, the grandfather paradox is an imaginary condition where a time traveller travels back in time to try and murder his paternal grandfather before his grandfather could meet his grandmother. If he succeeds in doing so, his father wouldn't be born, nor would he be born, and so he would never have actually gone back in time to have killed his grandfather. The contradiction is at times impersonated with autoinfanticide, where a time traveller travels back in time and tries to kill himself when he was a baby. If he would do so, he would never have become an adult to have travelled back in time and to kill himself when he was a baby. This conversation is significant to the beliefs of the time travels, as the theorists demand to know if these contradictions make travelling in time beyond the bounds of possibility. Some of the philosophers try to reply to these contradictions by debating that it could be the case that time travel to the past could be possible, but it would not be possible to alter the past in any circumstances. This is a thought that has been recommended in physics, Novikov's self-consistency principle. B. Theory of compossibility. According to the examination of compossibility and the consequences of altering the past by an American philosopher, David Kellogg Lewis, is destined to reason for the likelihoods of time travel in a one-dimensional outset of time devoid of building logical contradictions. Take the example of which David Lewis gives. Tim loathes his grandfather and would be much pleased to end his life. The only tricky situation here is that it's been years that his grandfather has died, but Tim eagerly wants to kill his grandfather and is so desperate to do so that he builds a time travel machine and travels back to 1965 when his grandfather was still young and kill him. The question here arises is, can Tim murder his grandfather? According to Lewis, the answer is hidden in the word can. He elucidates that the word can should be seen contrary to the circumstance of the relevant specifics linking to the situation. What if Tim had a gun? He has undergone years of training with a gun, a clear shot with no one to stop Tim from triggering the gun. Can Tim shoot his grandfather? Bearing in mind these evidences, it would seem that Tim can actually murder his grandfather. In other words, all of the circumstantial specifics are compossible with Tim murdering his grandfather. Nevertheless, while thinking on the compossibility of a certain state of affairs, we should collect the most comprehensive set of actualities that we are capable of gathering. Think through the fact that in Tim's world, his grandfather died in 1983 instead of 1945. This fresh fact of Tim's circumstance shows that he, murdering his grandfather, is not compossible with the present set of specifics. It is impossible for Tim to kill his grandfather, as his grandfather died in 1983, not when he was young. So Lewis determines that the sentence Tim doesn't but can, as is what it takes, and Tim doesn't and can't, as it is rationally not possible to alter the past, are not paradoxes. Both of them are true given the applicable set of specifics. The term can is vague. He can and cannot under various applicable actualities. So what will happen if Tim tries to take a shot at his grandfather? As per Lewis, there will be some problems that will happen, something will come in his way, he might slip and fall, his gun might not work, and so on. Any which way, there would be some analytical universal force which would stop Tim every time from putting an end to his grandfather's life. C. Presentism versus eternalism. There are many theorists who debate that relativity involves eternalism, the thought that the present and the past exist in a true sense, not only as alterations which happened or will happen to the present. Dean Rickles, a philosopher of science, doesn't agree with some of the recommendations, but records that the unanimity among theorists seems to be that special and general relativity are discordant with presentism. Time is viewed as a dimension which is equal to the special dimensions by some of the philosophers, and that the future occurrences are happening collaterally somewhere in various places and there is no objective flow of time. This view is debated and unclear. Presentism is a group of philosophers who believe that the past and the future exist only as alterations which have happened or will happen in the present, and they have no actual self-existence. According to this view, travel in time is impossible as there is no past or future for an individual to travel. Nelson and Keller debate that even if there are no objects in future and the past to travel to, there could still be certain facts about the future and the past, and so it is likely that a future truth about an individual travelling in time, determining to travel back to the present date, might elucidate the genuine looks of the time traveller in present. These opinions are debated by many authors. Presentism in typical space-time believes that only the present day subsists. This is not compatible with special relativity in the next example. Betty and Sam are onlookers of an occurrence X happening at the same time. For Betty, some occurrence Y is happening at the same time with X, but for Sam, even Y is either past or future. So Betty and Sam both don't agree about what actually exists in the present, which controverts the traditional presentism. This presentism tries to bring this together by accepting space and time of a single point. This is not satisfactory, as the substances coming and going from the here-now alter amid the unreal and the real, with the lack of a privileged here-now, which would be the real present. This new relativized presentism concedes that there are many frames of references and every frame has a diverse set of concurrent occurrence that makes it difficult to differentiate a single real present, and so either all the occurrences happening in time are real, distorting the dissimilarity between eternalism and presentism, or every frame of reference subsists in its self-actuality. Selections for presentism in special relativity look as if to be drained, but Gödel and other philosophers think presentism may be legal for certain arrangements of general relativity. D. Ontological paradox. According to the Novikov self-consistency principle, which gets its name from a Russian theoretical astrophysicist Igor Dmitrievich Novikov, all types of actions done by any time traveller or an object which travel back in time have always been a part of history all the time, which is why it is not possible for an individual travelling back in time to alter the history in any possible way. The deeds of the time traveller could be the reason of their own past that would be the cause of possible circular causation, at times referred to as predestination paradox, bootstrap paradox, or ontological paradox. The word bootstrap was made popular by Robert A. Heinlein through his story By His Bootstraps. As per the principle of Novikov self-consistency, the native laws of physics in an area of space-time comprising of time travellers is bound to be different from the native laws of physics in a different area of space-time. An ontological contradiction situation containing a tangible object could violate the second law of thermodynamics, argues philosopher Kelly L. Ross in Time Travel Paradoxes. Kelly gives the example of Jane Seymour's character from the movie Somewhere in Time, where she gives Christopher Reeves a watch that she has for years, and on travelling back in time, Christopher hands over the same watch back to Jane Seymour 60 years in the past. Ross says that the watch is an object which is impossible. It infringes the law of entropy and the second law of thermodynamics. If traveling in time makes the watch possible, then traveling in time itself is impossible. The watch must be completely same in look in both 19th and 20th century, as Christopher Reeves takes it with him from the future to the past and gives it to Jane Seymour. The watch cannot be like to itself because it was with Seymour for so many years, and then with Reeve it will definitely show signs of wear and tear routinely. Its degree of disorder or entropy will increase as per second law of thermodynamics. The watch is then carried by Ross back in time, and the watch will be more worn than the one which had been under the possession of Jane Seymour. The contemporary physicists agree that the second law of thermodynamics is an arithmetical law instead of an absolute one, so extemporaneous hitches of entropy or failure to upsurge in entropy are not impossible, simply impracticable. With it, according to the second law of thermodynamics, entropy must upsurge in structures that are sequestered from the outer world. So Igor Novikov debates that in case of macroscopic things such as watch, whose world lines form bound loops, the outer world can use energy to fix the wear or entropy that the object gets over its journey in the history, so that it will look as it was originally once the loop is closed. Fictional travel in time. There are three groups in which scientific fictional travel in time could be categorized into: mutable timeline, alternate histories, immutable timeline. Usually in fiction, timeline is referred to all tangible occurrences that take place in history, so that in the plots of travel stories where these occurrences can be altered, the time traveller is defined as crafting an altered or fresh timeline. The use of the word timeline is completely different as it refers to a type of chart which displays a certain series of occurrences, and the thought is also different from a world line, which refers to complete history of one single object and has been taken from the theory of relativity written by Einstein. A. Space travel or time travel. A demurral usually happens against in contradiction of the theory of time machines in scientific fiction, as they overlook the motion of Earth amid the date of departure and arrival of the time machine. The thought is that a time traveller can step into a machine which sends the individual to 1845 and come out in the same exact place on Earth could be said to have overlooked the problem that the Earth is moving through space and also around the Sun, which in turn in moving in the galaxy, so according to this argument, the time-travelling machine should actually resurface further away from the position of Earth on that particular date. But theory of relativity discards the thought of absolute time and space. In relativity there can be no general truth about the special expanse among the occurrences that happen at various times. Like the Earth on today and an occurrence on Earth in 1845, so no independent truth on which point in space at a certain time is at the similar position which the Earth was at some other time. In circumstances that deals in negligible gravity, in the theory of special relativity, the laws of physics function the same way in which all inertial frame of reference, and so no frame's point of view is actually better than other frames, and various frames differ on whether or not two occurrences at diverse times took place at the same position or separate positions. In the theory of general relativity, that includes the impacts of gravity at similar position or different positions. In the theory of general relativity, which includes the effects of gravity, all directed structures are on identical basis because of a characteristic called as diffeomorphism invariance. Time travel is a subject that continues to baffle many theorists and physicists. There are many people who continue to seek the answers for time travel as they believe that something like this was and is possible. The internet seems to be flooded with pictures and explanations of some weird people who seem to have popped up in simultaneously who are completely different from the people surrounded by them. Some say this could be photoshopped, but the truth continues to be unknown. Whether or not travelling in time is possible cannot be said. However, scientists continue to give explanations and theories and try to show the possibility or the impossibility of travelling in time. Authors and directors, however, seem to continue to entice the people with wonderful stories and movies of time travel and leave them puzzled. What if something such as travelling in time were possible, or what if someone could actually go back in time or change the future? In 1987, Enrique Caspar Irimbau published a story, L'Anacronopete, which features the first ever machine engineered for time travelling. In 1895, H.G. Wells' book, The Time Machine, propagated the idea of time travel by mechanical means. B. Time travel to the past. The origin of time travel is uncertain. There have been many writers who have written fantasy stories based on time travelling. Samuel Madden's work, Memoirs of the 20th Century, written in the year 1773, consists of letters from the British ambassadors in 1997 and 1998 to the envious in the past. These letters convey the religious and political conditions of the future. The narrator seems to have received these letters from a time traveller from the future, which he calls to be his guardian angel. Many writers like Alexander Veltman and Charles Dickens have written famous stories which involves travelling back in time. But truly, the book Paris avant les hommes, written by Pierre Boutillard in the year 1861, gave a clearer idea of time travel to a completely different level. There are many famous series that have shown time travel in a complicated and sophisticated way, which seems real at times. Star Trek, Back to the Future and Doctor Who are some of the famous ones. Humans have been shown travelling in time with the help of a vehicle or a machine and shuttle between past and future. However, the reality is much disarrayed. While some scientists say it is possible to travel in time, some of them disagree to it. There are many explained theories on time travelling which explains the probability and the improbability. History of time travel. A. Time machines. The fictional stories involving time travels have been with us for quite some time now. The first ever mention of time travelling through the means of a machine was made in a short story, The Clock That Went Backward, written by Edward Page Mitchell in the year 1881. In the story, this unusual clock took people back in time when wound backwards. There were later comments as to whether or not a clock counts to be a machine. However, later in the year 18 time and space is called the special relativity. Moving away from the Earth at special relativity velocity and returning would show that more time would have passed on Earth than that for the one who is travelling. Therefore, it can be said that relativity permits time travel. While many scientists believe that time travel is impossible, there are many who have spent their lives in the study of theories of the same. Here are a few of the theories of time travel. A. Wormhole. While many scientists believe that time travel is impossible, there are many who have spent their lives in the study of theories of time travel. According to NASA's study, general relativity could allow travelling back in time. However, the equations would be physically difficult to achieve. Out of many, one probability is to travel faster than light, which is 186,282 miles per second in vacuum. Another possibility is to create a wormhole between points in space-time. This is very much possible by the equation provided by Einstein, but they would collapse very swiftly and would be suited for small particles only. The wormhole. Scientifically, time travel is the idea of moving between specific points in time, comparable to movement between various points in space, with the help of an imaginary device which could be termed as time machine or a portal that connects distant points in time. Time travel is a well-known conception in works of fiction and philosophy, but traveling to a random place or point in time has a narrow explanation in theoretic physics and normally in aggregation with a wormhole or quantum mechanics. In an additional constricted sagacity, traveling in time one way in the future through time dilation is a recognized occurrence in special theory of relativity. However, traveling a noteworthy distance needs motion at speeds equivalent to the speed of light, which is not practical for a man to travel with the current technology. This thought of time travel had been used in many fictional works, but was best explained and made popular by H.G. Wells in his book The Time Machine, published in 1895, that took the imagination of the people about travel in the past. In the story, the character is transported to the past, in the prehistoric age, where he interacts with ancient creatures and comes across an ape-like ancestor. C. Time travel to the future. The mention of time travel to the future has even made its place in the Mahabharata, where King Ravyataka Kudmi travels to the heaven to meet with Brahma, the creator. When he returns to the earth, he shockingly learns that many years have passed. There is a Japanese legend of a fisherman, Urashima Taro, who rescues a turtle, and as a reward by the turtle, he gets to visit a palace undersea. He returns home after 3 days, only to find himself 300 years have passed in his absence. Theory of time travel. There are a few theories, special and general relativity being the most notable out of them, which suggest that appropriate geometrics of space-time or particular types of motions in space might make time travel into the past or the future possible. The commonly accepted and also well confirmed physical theory regarding the relationship between